get an idea for who wants to do which breakout topic. There also might be a slight problem with the video bridge for the live stream, maybe. I don't know. So those of you folks who are doing slides, if you wanted to like figure out a way through the interwebs to share your slides with people, just in case the video feed is not working, that would be nice. I will leave it to you to figure out how to do that. Oh, video is working. Right, so the slides are not going to be on the stream, is that correct? We're working on it. I just repeat the things that people tell me. All right, I see the breakout topics coming. While they approach, I might as well do the gold sponsor thing that it says here on this piece of paper that I'm supposed to do. Thank you to our gold sponsors, who are apparently the Knight Foundation, who I think has something to do with the big Motor Museum thing that's happening tonight, which awesome. Chemical Heritage Foundation, it's a good thing I went to that building, otherwise I would have no idea what CHF stood for, which is the only thing it says here. Ex Libris, which claims that it is the bridge to knowledge, and Index Data, whose logo actually says index, 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 index data. And those are our gold sponsors. Thank you very much. Okay, and so now there's this part where I need to, someone has written down for me what the things on the piece of paper that I can't see say. So let's do this. So we have 6 prospective breakout session topics. I don't know what the rooms are, so someone else is just going to have to figure out which rooms are appropriate for.
Rooms when the break ends.
What he said. We'll announce rooms and the break ends. So the topics are in order. I will read them out and then we'll do a quick vote. Docker, Fedora 4, IIIF, XML technologies, virtualizing vintage computing, and user testing. So think about those things, and we will have a show of hands. Who would like to break out about Docker? I see like that many, okay? So whoever's assigning rooms, that many. Fedora 4, how many are interested in Fedora 4? That's like that many. IIIF, that's like that many again. XML technologies, that's like that many. Virtualizing vintage computing, that's like that many. I expected the numbers to be bigger, which is why I made the benchmark here, but maybe I should have, I don't know. And then finally, user testing. So they're all like that many, basically. My sense is that there is sufficient interest in any of these breakout topics to be in any of the rooms. I'm going to let someone else figure out where that is. Does that sound like a plan? Oh my God, I'm on the screen. All right, so now my part of the job is mostly over. We are in group 2, which is 4 talks and a panel. And conveniently, the 4 people talking are also going to be the people on our panel. But first, the talks. We are going to start off with Mark. I meant to ask you how you actually wanted me to read the title of your talk, Ever to Excel Towards an Apologetics of the Spreadsheet on and Off of the Web. Mark Macienzo. Oh, something's happening here.
So I just wanted to, I'm Matt Miller. I'm going to be leading the moderating session, and I just want to kind of frame it up first before we get into the talks. So while you're listening to these talks, at the end we're going to do a panel. So if you have some questions or some kind of even better like interconnected themes that you see emerging, and you want to kind of help shape what we're going to talk about at the end, get those questions onto Slack or IRC or Twitter with the conference hashtag, and maybe add like a panel question or something like that. And that will really kind of help shape and make the panel discussion that much better.
All right, thank you. So first up we have Mark.
So I've changed my talk a little bit since I submitted it. Because of necessity and sort of the direction that I ended up taking while I was preparing for this talk. So I think one of the things we really want to think about is how ubiquitous spreadsheet software is as a technology. this ubiquity really encouraged us to use them as a starting point for different kinds of tasks. In fact, let's consider how you use spreadsheets. And this is like a degree of audience participation. So raise your hand, or if there's like sort of a, please don't shout it out for my sake, but like say it in Slack, say it in IRC, say it over Twitter. How many of you use spreadsheets on, say, a monthly basis? Wow, all right. How about on a weekly basis? A daily basis? That's pretty good, that's pretty good. And how do you feel when you use spreadsheets? How do they make you feel when you use them? And how do other people make you feel when they find out that you use spreadsheets? So I've noticed that spreadsheets are really often seen as the wrong tool for lots of jobs, particularly in libraries, archives, and museums. And I certainly know that I've been guilty of holding this view on some previous software projects I've worked on. So I've started to realize that that actually wasn't a particularly generous way of approaching user needs. So particularly if you've ever felt slighted by me in this regard, please accept my sincerest apologies. Also, I was asked by one of the duty officers, I am wearing a yellow lanyard. I am giving you my explicit permission to take a photograph of me while I am on the stage. So before we get too much further, I should probably articulate what I mean by a spreadsheet. I think it's a file with a specific form, which represents data in a tabular format, and within which formulas can be applied to that data. So spreadsheets are read and interpreted within the environment of spreadsheet software, such as Google Sheets or Microsoft Excel. In the context of spreadsheet software, the data in tabular format is addressable through coordinate-based references to cells or by address or category-based ranges. I want to emphasize, however, that tabular data on its own does not adequately qualify as a spreadsheet, meaning that a freestanding CSV-based data set doesn't qualify as such either. Nonetheless, such data sets can easily be converted or understood using the paradigm of the spreadsheet by loading it into spreadsheet software or an environment that provides somewhat similar functionality, such as OpenRefine. This specific consideration allows us to see spreadsheets as the unification of tabularly expressed information and formulas. To put it plainly, as a form of information, a spreadsheet can be seen as both data and a program. This combination is a handy packaging format. What's going on with my slides? Which makes it easy to ship your data and the tools that you use for calculations and methods for processing and analysis around with others to work with them. The increased ubiquity of spreadsheet software on personal computers over time, I think, has really expanded the potential for end users to work with data directly in flexible and independent ways. And the unification of data and program has allowed for collective collaboration within groups of users working in a common domain. So this is a long-standing trend that I think has been fostered by the underlying design of spreadsheets as an application tailored towards end user needs from their inception. As we review the history of spreadsheet software development for personal computers, and arguably the spreadsheet revolution really originated in the development and release of VisiCalc by Software Arts. In his 1984 article on the emergence of spreadsheet software in Harper's, Stephen Levy describes the source of the idea by Dan Bricklin, VisiCalc's co-creator, as originating in working on a class assignment while he was in an MBA program that required Bricklin to complete ledger sheets to analyze the implications of a merger between businesses. More specifically, Burton Grad describes Bricklin's motivation as also stemming from his frustration that recognizing that then current methods of programming were failing him to solve real-time needs based on the interruption and time it took for him to run a simple program in a time-sharing environment. In addition, Levy notes that Bricklin's desire to make an end-user-focused version of a spreadsheet application designed to run on a personal computer as a potential means to simplify this analysis was met with derision by his professors. As stated by Levy, why would a manager want to do a spreadsheet on one of those toy computers? What were secretaries and accountants and the people down in data processing for? So I'm not going to really unpack the kind of gendered assumptions there, but I'll let you do that. VisiCalc's co-creators, Bricklin and Bob Frankston, have acknowledged many times over that the product was designed in part to give more power to the user. While Bricklin himself has noted that neither he nor Frankston were originators of the computer-based spreadsheets in general, he describes the value of what VisiCalc provided as a what you see is what you get model of interactivity, wherein a user could point to change values, see figures automatically recalculated based on stored formulas. More broadly, VisiCalc also heralded a change in how users could approach computers. Martin Campbell Kelly describes a paper given by Frankston in which he compared the potential of VisiCalc to how the projected growth of the telephone system between the 1930s and the 1950s would lead to an unsustainable number of operators. Ultimately, the resolution in the case of the telephone was to provide telephone users with the ability to dial telephones themselves. Similarly, Frankston realized that VisiCalc made everyone a programmer. Similarly, Bricklin also cites Jean-Louis Gasset's description of his encounter with VisiCalc. That was the day that I realized that you didn't have to be a programmer anymore to use a computer. Approximations, trial and error, simulations. VisiCalc is intellectual modeling clay. It lets you program without knowing it. The power of VisiCalc, and arguably spreadsheets overall, then is this fundamental tension wherein programming is both perceived to be fundamentally accessible and simultaneously unnecessary to leverage the potential of the technology. In this case, another strength of spreadsheet software on personal computers, particularly with early applications like VisiCalc, is that they provided this power and control to end users with a degree of constraints within the user interface. Bonnie Nardi and James Miller have identified two specific factors that have demonstrated why spreadsheets work so well. In their words, computational techniques that match users' tasks and that shield users from the low-level details of traditional programming, and a table-oriented interface that serves as a model for users' applications. In other words, these are the formula languages targeted at users trying to get stuff done in the constraint of that grid-based format. Specifically, the visual constraint of the spreadsheet's tabular format for data and formulas allows for a clearer understanding of complete their work at hand. In Nardi and Miller's words, as a user begins developing a spreadsheet, the tabular grid provides an overarching structure into which the parameters and variables of a model are cast. As the spreadsheet begins to take shape, the user views the emerging model and evaluates its accuracy and completeness. Within the framework of the rows and columns, the user can restructure the model by rearranging rows and columns and by adding new parameters as they become known. A spreadsheet model is grounded in this distinct tabular format of rows and columns and is constructed in successive approximations as the user critiques the emerging model. Frankston himself notes that the grid was key to the usability in VisiCalc, which provided a simplified representation of the structure in which users would be working. If anything, in Frankston's words, the big break with VisiCalc was that the grid actually reduced the amount of interactivity. The original design was much more flexible and powerful. The key was the grid, which gave you a framework for reference and simplified everything. It's almost the opposite of what people think. People think that more features make a design easier. It's actually a reduction in features that make it feasible. Later, as people became used to it, the basic idea was reducing the grid. In her recent book, Calm Technology, Amber Case states that a product utilizes the right amount of technology becomes invisible more quickly. By constraining options in terms of data representation up front, spreadsheet users and developers can work to address their work at hand more directly. Both beyond and including VisiCalc, Martin Campbell Kelly also describes the personal computer spreadsheet sector as being notably responsive to user needs and usability concerns as the market emerged. For example, in describing Lotus 123, Campbell Kelly writes that in a usability-related development was most often targeted at providing user support in environments that were lacking an in-house information technology staff. Not only did Lotus 123 provide macros, which assisted end users in automating repetitive tasks, but Lotus also provided extensive documentation and infrastructure to support tutorials. And by providing a development kit which allowed 1, 2, 3 users to easily spin up user groups intended to be broader than those targeted previously at computer professionals. In addition, Lotus ultimately encouraged the development of add-ons for 1, 2, 3, such as spreadsheet templates and additional enhancement applications that augmented the functionality of the application. Campbell-Kelly notes that while Lotus was originally resistant to encourage the development of these add-ons, they recognized the complementary nature of these products to address user needs that were likely unable to be addressed by a single company, and that a regional spreadsheet industry developed in the metropolitan Boston area over time. As such, Campbell-Kelly demonstrates that by the end of 1986, Lotus had a very definite vision of 123 as a technological system, a platform consisting of a spreadsheet engine that could support an entire system of products. By extension, spreadsheets and the other actors that interact with them as boundary objects can also be seen as a socio-technical system, not only through the case of Lotus 123's ecosystem of add-ons and vendors that developed and marketed them, but also through the collaborative nature of spreadsheet development, as described by Bonnie Nardi and James Miller. Using ethnographic methods, Nardi and Miller established in their research that the creation of spreadsheets is most often a site of co-development, wherein they come about through the efforts of a group of individuals working closely together. In addition, Nardi and Miller view spreadsheets as an excellent medium for supporting such co-development, as they serve as a conduit for communication, particularly in terms of how they support design, development, and use by people with different levels of both programming and domain knowledge. I believe that this bridging function across levels and areas of domain knowledge is incredibly important, in that it improves the potential for dialogue around the work at hand, and such code development can allow for sustained collaboration in the longer term, allowing trust to be built across disparate teams. In summary, spreadsheets as they've developed over time provide a useful instruction in terms of the types of interaction and collaboration we should be considering around software and other products and services that we develop. I'm really deeply curious why we haven't been able to address this in the same sort of way in our profession, and why we're unable to develop transformative tools that empower users to work more closely together to solve common problems. The continued presence of spreadsheet in our domain of cultural heritage is precisely provided because they provide an adequate degree of constraint and power, particularly in institutions with small staffs, lower resource institutions, or institutions where it's frankly not feasible to develop custom solutions that are seen as well architected. While not strictly speaking as a spreadsheet application itself, I think these same types of considerations in terms of collaboration and usability can account for the success of other applications like OpenRefine. They do just enough for us to allow us to do our work. They make us feel powerful and productive, and we can work closely with others to establish a shared network of solutions. In opposition, denying users with the ability to work with the tools in which they feel the most productive demonstrates a lack of empathy and understanding, and can frankly hinder the efforts to develop a healthy collaborative environment between users and developers. I expect this community to carefully consider how productive and empowering tools are developed when constraints themselves add value and the likelihood of comprehension, and how to ensure that we can build on this legacy developed over more than 35 years. Thank you.
All right, up next we have maybe I can make the slides come up because I did that whole presenter mode thing a minute ago. There we go. Hey, awesome.
So, hi, I'm Christina Harlow. I work on metadata at Cornell and lucky enough to do so there. My slides and speaker notes, which I'll try to follow the speaker notes closely, are available at that bit.ly link. It's bit.ly/getyourrecon. And with that, let me move to my actual starting slide. So today, I'm going to be talking about reconciliation, otherwise known as entity matching, otherwise known as one of the big elephants in the linked data libraries, archives, and museums room. But this talk is also a brief narrative of my work in library metadata so far and how much reconciliation work has overlapped with my experimentation and goals. So with that said, let's go back in time. And let me talk about a project workflow and project blocker that probably sounds really, really, really familiar to most of the people here today. So the narrative goes this way. Someone discovers that it would be really great if we had this database that pulled data from all of these other sources. But our database focuses on bringing together data around a particular entity type that the other data sources treat as secondary. We could offer all kinds of new, let me get my notes up. We could offer all kinds of new searching and querying, linking, all these functionalities around these entity types. So people go off and get the data, they get really excited, they maybe flatten it into tabular form to look at it, and then they realize, damn, our metadata is really messy. How am I going to align the entities I want to focus on across data sets, much less within the same data set? We don't want to have some people, the same entity, linked, not linked correctly because the labels are a little bit off. We don't want to have two separate entities linked because the labels share some similar characteristics. What do we do? So yeah, we see, man, our data is messy. I know, let's hire a student or an intern, or let's get a staff member to just go through this. Yeah. And so this is where I enter as a staff member into my first metadata focused job in libraries. And if you've ever said, let's just get a student to the reconciliation, you owe me a beer tonight. Thanks. So I manually search these authorities, going through these steps because they do frame what I'm going to be talking about later. I choose the best option, and how we do that matching, how a human does that understanding and matching is something that's very tricky for trying to script reconciliation later. I paste just the heading back in and wonder why on earth aren't we using identifiers? When did headings become identifiers? What is going on here? And I repeat forever and ever, amen, dying of boredom, and worse, entering lots of errors because I'm doing this manually and probably zoning out towards the end. So you could do that or don't do that. There must be a better way to accomplish this. And I was lucky enough with that preliminary project to have the flexibility to start looking at how else could we approach this. I had some freedom to explore some ways to do it, and I had some tools that may be of use, some tools that were thrown at me like, well, they might help, see. So this is where we switch our workflows up. I'm sort of glad the sound isn't working because it was freaking out anyway. So early on, OpenRefine was offered to me as something that could help with data munging work. It's a tool that a lot of people here are probably already familiar with, so I'm not going into it. But it was originally presented to me as like, here's something to help data normalization, and the things that stood out were the OpenRefine Standard Reconciliation Service API, and the linked open data or load-refine fork of OpenRefine that had a Sparkle Reconciliation Service API. And so I need to stop here for a second and touch on what I mean by reconciliation. This and my OpenRefine's understanding of it and my work going forward have been really influenced by OpenRefine's understanding of it. And I also just don't want to get mansplained about this later on. So reconciliation, I am saying specifically, I've got a bunch of data describing an entity. I want to match it with a bunch of data describing this entity over there and create some link that says that these are the same entity. I'm making no assumptions about what the starting or ending data is looking like. It could be literals, it could be strings, it could be URIs, it could be identifiers, it could be typed data, who knows. But what you'll hear about more specifically is that reconciliation is matching things to things. So a URI and maybe the named graph generated from it with this URI over there. We do some of this, but more of what I'm talking about is entity resolution. So this is where we have a string, and then I'm trying to get a URI for the entity described by that string. You've got lexicalization, which is where we get the labels for the things. That's a little bit less involved as we're trying to get our identifiers in there. So I don't focus on any of these particularly. I'm sort of talking about entity matching generally when I say reconciliation. So having covered that, let's jump back to what I did and how it influenced me going forward. So with OpenRefine's reconciliation service APIs and a lot of coding templates that were built by people in this room, including Ted, who will be talking right after me. Thanks, Ted. I could get data out of OpenRefine. I could match it with an authority or some external data set in some way. So here I'm hitting the id.loc.gov query or lookup API. And then I could return that, and my service API says, okay, how am I going to generate a score from this? And what is the information I want to send back to OpenRefine? This became the template for later scripting-only efforts, taking data to be matched, including other data from a related row or record or whatever it is we're connecting to that entity in the original data set, creating some sort of matching, performing some sort of normalization, querying, and then getting back the top few matches. So this leads us to, yes. This leads us to matching and open refine. Holla, this is fantastic. Hooray, we got Missy Elliott linked in our data set. And so this project sort of workflow I saw repeated in many other places. With MARC data, in particular at my last job, we were looking at replacing a lot of authority vendor functionalities. And so we looked to MARC Edit, which I have a screenshot of up here. So we were looking to MARC Edit because we really couldn't afford the authority vendors updates, and we weren't involved in NACO or the name authority file creation process enough to really affect change there or get headings made when we needed them. So we looked to MARC Edit, which has very similar functionalities to what we saw in Open Refine, among many others. I'm just focusing on one. And based off the controlled headings in MARC, you could match that with headings in the Library of Congress or OCLC services like VAuth and FAST. So it does the matching, returns back the URI. You can see it in the subfield 0. Fantastic. But we quickly see where these services hit their limits. And so at first, it was just getting automatic querying of APIs and the various interfaces was a coup. I was so excited. But then I saw that there were mismatches. There were lack of matches. There was needed normalization. There was missing data. For Open Refine and Load Refine, there's a lack of maintenance for these tools, meaning a lot of the functionalities I really hoped for, like Sparkle Reconciliation Service API, became just a glimpse of what could have been. Hint, hint, any Java developers in the room. I will buy you beer if you maintain these. So I started to load more and more fine-tuning into my own reconciliation service API functionalities for Open Refine. But as the data munging to support and rank matching began to get more and more involved, and the data sets began to get bigger and bigger, I saw the limits of these tools and APIs. So what about the limits of those external APIs? What am I talking about? Well, so with the id.loc.gov lookup APIs that I was using, we see that, first of all, there are two different APIs you want to hit. One queries for preferred labels, one queries for alternate labels. So you're hitting two different APIs. One returns JSON, the other one returns XML. So you're parsing two different objects. You have one heading, you don't know if it's an alt or a pref label, you just want to get it matched to something. This is an extra layer of data munging. We had where there was a lot of timing out, we had some false positives for place names that we really didn't want to see mismatched. So here we've got a former Native American city that was matched to the archaeological dig that was on the spot the city used to be in. We really don't want that mismatched. We also had false positives for people we didn't want to see matched. So our graduate students, we would do a lot of work on the records for their recitals, dissertations, theses going into our catalog. We wanted to do that matching, but then we saw that our graduate students were getting overwritten by people who happen to be in the name authority file. We don't want our graduate students to disappear. With id.loc.gov, there's some peculiarities about some of the more granular aspects of the MARC data, making it over to the RDF serializations. So here, I'm sorry, yeah, I'm showing MARC XML on the screen. Get over it. I have MARC XML coordinates up here. Really great for Richmond, Virginia, my hometown. I want to pull these coordinates, fantastic. I go to see if I can work with the RDF serialization of that because it's a little bit easier to munge for me. The coordinates become a MADS note off a blank node. So we lost that structured data. To be an equal opportunity data access critic, the Getty Sparkle endpoint was something that I was really excited about working with because as I was working on that original matching project, we were using a lot of Ulan. They were moving to linked data at the time. But it doesn't appear that the linked open data refine Sparkle reconciliation service extension works with anything other than Virtuoso endpoints. If someone has a counterclaim to that, I would love hearing it. So the data dumps also from Getty were a little bit too big for me to work on my local machine. A lot of this was like fly-by-night experimentation on my own. So this is where I started messing with linked data fragment servers to make more efficient querying for these reconciliation services. And you'll hear more about those in the next talk, I think. I did try to do some reconciliation with Wikidata. There is a Sparkle endpoint in beta. There's no fuzzy matching, which is not too surprising given it's a Sparkle endpoint. They do have some very good identifier matching though. So this is the FAST identifier, this is the VOF identifier, this is the Library of Congress identifier. That's really nice. But talking about identifiers, so the very top is the results from a Wikidata Sparkle query, and you see that the FAST identifier is just a series of numbers. Over here on your left-hand side, there's the FAST record that shows that the FAST identifier is FST and then a certain number of digits prepended by zeros. Over at the bottom of the FAST record search result over here on the left-hand side, you see a link to the Library of Congress number, but that's formulated more in the permalinks sort of style, or what you would see in a MARC record. So you've got DLC NO underscore numbers. Over in the Library of Congress, the authorities.loc.gov search, you see the LC control number, which is just NO space numbers, and then the URI from Missy Elliott in id.loc.gov. That's a hell of a lot of data munging just to match identifiers. So yeah, tell it, Missy. Okay, the linked data that you're doing is incomplete. So to fully realize the benefits of linked data and the huge amount of entity matching data remediation work, there's a huge amount of this that needs to occur first. I don't mean just in general maintenance. I mean, we've got to shift a lot of our data to match these entities so that we can represent them in linked data. To accomplish this, I've begun experimenting with some matching algorithms and external data API querying that can help avoid these false positives, data matching false negatives, try to do some of the general normalization work we need to do to have data sources talk to each other. So this is the basic overview of a matching algorithm I'm trying with personal names and MARC, as personal names is something I'm very committed to try to figure out, particularly doing big batches of this as we migrate our MARC data, for example. So if it has a subfield 0, which is URI, then I just try to grab that identifier and then match it to other identifiers using Wikidata or other sources. If it has some other values in the heading like dates or qualifiers, that's very specific to Library of Congress, I query Library of Congress first and then try to get that match back and link it to other identifiers. If it has none of that, I'm looking at how does this name label match this other name label in some sort of way? Okay, well, building off of that ranking, does the work title for this related record match the work title in VOF, Wikidata, or some other source? Or does it sort of match it? Can we build our score up from that? Do the role terms match? Because there's actually a lot of role terms in Wikidata, which was surprising and very helpful. Affiliations is something I was really hoping to match, and it just hasn't panned out because they're not as present as I was hoping. Something similar with our institutional repository DC data, which I was looking at. We would look first if they have a URI. They don't. That's why I'm doing this. This is where you have the query and the other data probably in the same field. So you're going to be doing regular expression matching to try to pull things out like dates or even role terms. We see a similar matching algorithm coming forward. So I'm stumbling toward this. This is an example, and the full data set for a sample run of this matching reconciliation service scripting that I'm writing is in that bit.ly link Google Drive doc that I shared with you. But you can see that I've got the query and I'm trying to generate scores for a variety of different external data sets and then get the URIs from them. So, concluding, in case you were wondering why on earth I included all this Missy Elliott stuff, beyond the fact that her music is perfect for data munging, all of this crazy reconciliation workflow stuff that I'm sort of duct taping together with like poorly created Python and glimmers of understanding of how data works in other places, it's what I've dreamed up, it's what I've pulled together, it's what internal stakeholders somewhat expect. Basically, it's just what works somewhat. And so I hope this work comes across more like a Missy Elliott video where you're just sort of like, that's crazy, what are you doing? But it works, and it works with what you've got. So thank you.
Next, Ted Lawless is going to tell you how to build your own identity hub, assuming I can find his slides. There we go. And presenter mode. Presenter mode. Presenter mode. Take it away.
Okay, thank you. Can you hear me in the back? Okay. No. All right. So, thank you to Christina for setting up my talk well, because I'm going to talk today about how you can build your own identity hub and to actually start working on some of these challenging issues. And here's my abstract, and we only have 15 minutes, so it's pretty ambitious to build an identity hub in 15 minutes, but we'll give it a try. And I'm going to start with some observations about what I've seen so far with some of the linked data that we're producing. As Christina said, the linked data you're producing is not complete, and that's a different way to say one of the things I've observed. So I'll talk about that for a bit. Then I'll work through an example of creating what I'm calling an identity hub. So some piece of software or tools you can deploy locally that capture the identities in the form of these URIs or identifiers in your local data to real world people, places, things, and so on. And then I hope to, if the slides cooperate or the Wi-Fi cooperates, show an integration, a live demo of doing something useful with that data. And since this is code4lib and we're all interested in tools, I have a slide with links to tools that I think you should take a look at. And finally talk a little bit about some future directions. So my motivation for working on some of these issues stems from going back and taking a look at the 5 principles of linked data that Tim Berners-Lee put forward in 2006 and later revised. And it's, I think we all in this room are enthusiastic about this web of data rather than web of documents that he conceived. And the intro quote, or the first paragraph of that article, talks about the semantic web isn't just about putting data on the web. You need to link it so that people who have some of your data can find more. And that was the point I think Christina was making. So for the motivations or the observations I have come up with, the last 3 years or so I've been working on the Vivo project, which is an open source project, part of DuraSpace, and it's in use at over 30 organizations here in the States, more around the world. And what makes it a little interesting, I think, in the context of semantic web and linked data is that it was built with W3C semantic web standards at its core. So RDF, Ontology, Sparkle. There isn't legacy data in terms of that application. It is built with RDF. So it's, in some ways, some of the things that we want from our newer systems. But I noticed when looking at or working in this community is, despite some kind of large-scale efforts, there isn't a lot of 5-star linked data. So each of these systems will have a URI that represents a journal or a person, and there aren't identifiers to link across the systems or out to more authoritative sources. And I have some theories as to why this hasn't happened, and you probably have some as well. And I think Christina proved just before us that it's not happening probably because it's difficult and time consuming. It's hard work to resolve your local entities to central authorities, especially when you start working with data it's not really been curated by librarians over the years. So if you start working with grant data, let's say, or data about positions that faculty members had at various universities, you realize that there hasn't been authority control done on this data, and you have a lot of the strings to things problems. And people aren't working on it probably because there's no clear immediate benefit. What can I do with it right away? How can I leverage this emerging web of data right away? And it's also overwhelming. We're all familiar with this diagram, and how, as a single, a small team in a university, how can I take part in this web of data? So what we really have is something like this, where we have a bunch of applications with data repeated across them, or they're all describing the similar things, but they're not connected by identifiers. So even if they're outputting structured data, that structured data isn't connected. And what we really want is something like this. Wouldn't it be great if our applications, even the applications running inside of our organization could query a hub, or if applications that we're all running could query a hub? So what I'm going to propose is a process where you can start with identifying an important collection at your institution, so maybe don't focus on the enormity of all the data you have, but focus on something that's really important, and take that data and match it to a central source using some of the techniques that we just heard about, and then map that data to RDF and publish using a linked data fragment server. And here's a diagram of this process, including the omnipresent CSV or spreadsheet in the top left. So what I'm going to walk through now is this process. So starting with a spreadsheet of data, I'm going to match it with Wikidata, and I chose Wikidata because it's emerging as a very good source of identifiers. It's not only read, but it's write, so you can get an account and go in and fix data that if you find problems. And then we have the black box, which is a really important critical process that Christina was just talking about, and we're going to publish that as RDF. So the collection I chose is about 8,700 journals from the Web of Science, which is important to the organization I work for. And that is academic journal data for 8,700 journals. I'm going to run it through this process and publish as linked data fragments. And you can see the URL there. I have some code and examples in a GitHub repository you can take a look at. So now to the process of matching this data. So I start with my simple 3-column CSV with a local ID, a title, and an ISSN. I run it through my black box matching process, and I come up with the Wikidata ID, all of which start with Q there in the right-hand column. So I did that. I used a Sparkle query to get all of the ISSNs out of Wikidata, and I found about 7,300 just matching on the ISSN, so no smart algorithms in this case. And then I used Python, but there are plenty of tools to help you with this, to convert that CSV data to RDF. And I would just like to draw your attention to the last line there, which is this OWL same as statement. So I'm saying that this local thing in my system is the same as this entity at Wikidata. So this is the minimal RDF for one journal. And then I published it, and you can go to this URL. It's running on a free instance of Heroku, so you could query and browse this data. And one of the appealing things about the linked data fragments concept in the software is that it's a lightweight way to publish linked data. I encourage you to go out to their website and learn more. There's some really good videos and examples. So now that I have linked my data, I want to do something with it. How can I tie this together and actually build something useful out of the data that I've linked? And in this diagram, we're going to start here at the purple page there, my application, which is just a web page, and I'm going to send my local identifier out to this hub that we've created, and it's going to pass back the Wikidata identifier, and then I can go out to the web of data that exists and query it and pull back some more contextual information about the thing. So querying the web of data. And here I put together a demo of using this using just JS Fiddle, and I'm going to attempt to pull this up. I'm not sure what happens when I switch out of presenter mode. Okay, so the implementation details here probably aren't that relevant. This is kind of a quick proof of concept of what you could do once you have matched your data. So you can see on the lower right, that we now have a cover for the journal Nature, an abstract, and the fact that it's a scientific journal, none of which were in my source data. So by establishing these links and putting them into this local hub I have, I was able to query just in the browser more authoritative sources and pull that down to provide context. And you can see in this implementation, I've just embedded the local URI in the HTML markup to kick this process off. So you can imagine your local system can probably do this. And I'm going to just switch the identifier to another journal to show you that it is live. Wondering why I'm getting dictionary here. There we go. So by just changing the identifier embedded in the markup, I'm able to query my hub, go out to the web, and get more authoritative data. And just do one more quickly here. We're done. There we go. One more. So prove that it's actually live and querying this hub that I have put together. Okay, so back to the slide. So that's something you can start doing immediately that is useful and relevant to your work. So we all have all these different applications representing the same things. We can load some data into a hub and start pulling it in and providing context. And this is just, scratching the surface of some of these ideas of linked data that we're all interested in. What I think could be even more powerful, and I've experimented with in the Vivo community with organization names, is once I've resolved my local entities, I could also communicate with some peers and match my data to theirs, so then they don't have to build their own hub, or they could build a different type of hub, as long as we're sharing the URIs. So in this example, I've added 2 more URIs for Vivo instances at Cornell in Florida, and I could share with them the JavaScript that I just showed you, or some other service that I build on top of this, and we can all kind of use the same hub for our work. So on to the tools, and I won't say a lot about this, but I encourage you to find me in the hallway or tonight at the reception to talk about this, because tools are important, as Mark's talk alluded to. I like Python. Here's some of the libraries I used. But another tool that I think is quite powerful, I didn't talk about it here, but it's called Karma. It comes out of a research group at USC. And it's a graphical tool for mapping data to ontologies, lots of machine learning and things built into it. It's moving along in terms of new development at a great pace, so I encourage you to take a look at that. Linked data fragment server, they focus on a low-cost way of serving linked data that we can all use or start benefiting from. I also encourage you to take a look at Vivo as a platform. It's mostly used at the moment for research profiles or research networking, but it has a lot of capabilities built in, like an ontology editor, graphical interface for editing RDF, user-facing forms, user accounts, so you can create accounts for other people who might be managing some data that you're creating. It can also build a Solr index of your triples, so you can build like autocomplete services and things like that against your own entities. And then, just some future directions that we could head as a community is to do what Christina said and talk about our reconciliation techniques and tools so that we can make that entity matching process more robust and work out some of the kinks we saw. We can create services around things like linked data fragments or other things, other tools that emerge, reuse those across the community, obviously expand to other identity types, and have more hubs. So eventually we have something like this where we have all of our applications all querying different hubs. The hubs can connect to other hubs and connect to authoritative sources like Wikidata and GeoNames. So that's what I have. Here's some more links. I'm here for the remainder of the conference and would love to talk about any of this with you.
Thank you, Ted. Before we move on to you, Matt, just a reminder, if you have questions for the panel, you can send them to the conf_QA Slack channel. And now is probably your last chance to do that in a meaningful way, so remember. All right, so now we have Matt Zumwalt, who's going to give us, tell us something about trust.
How do I get up?
Oh, right, I might want to help you put your slides up. That's my job, isn't it? Let me see, somewhere. Oh, Keynote? Oh, come on. Oh, hey, it works. I don't know how to make presenter mode. Will that work? All right, cool.
Thank you. Wow, we're really like hammering you with information. Can you hear me? Okay. So in addition to everything that has already been discussed, I am interested in trust. And in particular, I'm interested in how trust and trustworthiness manifests in systems where people are exchanging data. So why am I interested in trust? Well, there are a lot of reasons why I'm personally interested in it, but why am I talking about it here? It's because there's a rhythm in the computing world that moves between centralization and decentralization. And we are currently in the midst of one of those turns, where we have centralized and we are moving back towards decentralization. And in a decentralized environment, trust becomes extremely important. So this cycle in the technology world, first we had mainframes, we went to personal computers, we re-centralized to the server farms, which we call the cloud, and now we're moving towards something that doesn't quite have a name yet. People call it Internet of Everything, Internet of Things. It's a little bit vague, but the general pattern is lots of stuff spread around everywhere. So do you remember mainframes? I don't. I've heard about them. So let's talk a little bit about mainframes. They were very big, very expensive, labor-intensive to maintain. And we mainly interacted with them through thin clients, which were machines that had little or no memory, little or no processing power, and all of the processing and storage of information was done on the mainframe. Over time, the personal computer began to develop, so we had more and more processing power and storage capacity spread across the clients. And eventually, we started connecting those clients directly in what we called the internet, which then made it possible to create the World Wide Web. And in the World Wide Web, the key thing to think about is that anyone participating in that web could host data, and those participants could directly reference each other. Each machine connected to the web could reference other machines on the web that were hosting data. And one of the key elements of the power of the World Wide Web and why it has had such an impact on the world was that it scales. It's repeatable, it's decentralized, anyone can opt in to participate, it's easy to join in, or relatively easy, the barrier to entry is low, and it scales to what we now call web scale. So by contrast with that, with data, there's a different story. Data, in order to represent data, you need structure. You often need it indexed in some way so you can search against it. So whether we're representing financial records or inventories of objects or representing ourselves, our lives, our experiences, our careers, for those cases, when we're representing data, we rely on centralized servers and centralized hosts. As we have relied on that increasingly and relied on that data increasingly, we have de-emphasized this distributed network where we directly reference each other, to the point where now, with the modern web where we rely primarily on the cloud, we don't reference each other or almost never reference each other directly. Instead, we're referencing representations of ourselves and representations of each other that are on these hosted central servers. So we have moved from a centralized system to a massively scalable decentralized system back to a centralized system. And so what's next? Oh, well, what are some of the ramifications of this centralized system? There are a lot. I could talk for a long time about all the ramifications in all sorts of directions about ownership and copyright and who's making the money and who's bearing the burden of hosting the data. But the most important thing here is that this situation is not actually capable of accommodating the volume of data we're producing, the type of work we're doing with that data, and the patterns of innovation and the new innovation we're going to be pursuing over the next 10 to 15 years around the data we create. So what does a decentralized system of data look like? Some information about that scaling thing. These numbers are a bit confusing because when you get into estimates of how big is the internet, how much data is out there, it gets really fuzzy. But in a recent white paper, Cisco said that by 2019, the data created just by Internet of Everything devices will be 49 times higher than the total amount of traffic that moved through the internet in 2014. So another way of thinking of that, in 2012, Seagate estimated that the total storage capacity, the total digital storage capacity on the planet in 2012 was 2.5 zettabytes. In 2016, about 10.4 zettabytes of data will move through data centers. So if you think about the redundancy of how often the same data moves through a data center in a year, that total amount, 10.4 zettabytes, by 2019, in 3 years, they're estimating that Internet of Everything devices alone will produce over 500 zettabytes of data per year. So we're talking about a massive explosion of data, but also a shift in the nature of the data that we're producing and a shift in the nature of how we relate to it. So we need to accommodate that kind of, we need to accommodate innovation and changes in how we move that data, how we interact with it, et cetera. That's exactly the kind of situation that a centralized system has trouble grappling with. So what does a distributed data web look like? First of all, it's a distributed system where everyone can hold whatever data they see is important. So for example, we each hold the data that we care about, that we see as important, and we can share copies of it with whoever we choose to share those copies with. Now, anyone can do this, and anyone can share data with whoever they want to. So there is no centralized server. So anyone can opt in and share data amongst their own small networks. But of course, then it's useful to share across those networks. So groups of people can choose to aggregate data and contribute data to aggregated places and choose how to arrange that information, how to represent how it fits together. And if there are disputes about how it all fits together or how it should be aggregated, different communities can assemble the same information differently. Because we each hold our own data, we contribute it where we see fit. Now this scans to a heterogeneous system with a broad range of data. Whoever cares about that data chooses to represent it as they see fit. Now, again, this lets us scale. This gives us a system that's not centralized, where anyone who has data they care about can opt in and start sharing the data with the people who care about their data. So this gives us access to that web scale pattern again. But the key thing to observe is that this decentralized system relies on trust. So let's think a little bit about what are some elements of trustworthiness that are going to be really familiar to a software developer and especially familiar to anyone in the libraries world, where some of the different elements of trust and trustworthiness would be authority and reputation, integrity and provenance, synergy or compatibility in the sense of do my intentions match with your intentions? Are we working on the same thing? Are we representing things in the same way? And then also consistency. Can I rely on you to keep producing things in the same way that you did in the past? So those are things that librarians deal with all the time. But really, organisms have been figuring out in ecosystems ways to deal with these problems for millennia. For eons, humans have been dealing with them for millennia. Librarians have been explicitly dealing with it for centuries, and the software development world has been dealing with it quite skillfully and very pragmatically for decades. So we have solutions for these problems of trust. We just need infrastructure that lets us build those patterns around data. And so that's why I'm working on something on this project called John, or Dat John, which you could say is a Git for tabular data, because fundamentally, in order to build these systems of trust, we need transparency and reproducibility. As we hear often in the research world, those same topics, and in the business world, those same topics become very prominent for the same reasons. So the fundamental idea here of why you would build a Git for data is to understand the idea that history has branches. So what do I mean by that? When I make a set of changes to a data set, whether it's 1 change or 10 changes or 1,000 changes, I can represent that set of changes with 1 commit that describes what those changes are, why I made them, who made them, and when they were made. That's 1 commit. Once I create that commit, I can share it with whoever I want to share the data with, and they can add more changes. And they can add more changes in parallel. And then when we choose to, we can merge changes, which allows us to move towards consensus about what a set of data should look like given a certain set of priorities or a certain set of goals. Once you have these trees of histories of changes, then the most important thing is that you can reference specific points in that history and get the data as it looked at that point in history and prove that what you have retrieved is identical to what the data looked like at that point in time. So this is what Git allows software developers, Git and its peers allow software developers to do with source code. And now we need something similar for data. What kind of data? Well, files are data, metadata are data. All forms of data have this pattern of history that develops. So the other question to ask is that once we build this tree, how does it get replicated? How does it get shared across a network? We have 2 options here. You can take a client-server approach, or you can take a peer-to-peer approach. So if you take a client-server approach, sorry, the colors are wrong. There are purple ones in the center that are the servers. So in a client-server setup, if I make changes, I submit them to the server, and then other clients can pull down my changes from the server. We can do that in parallel. Many people can make changes, submit them to the server, they get redistributed to the clients. The alternative, in a peer-to-peer situation, there is no central server. When I make changes, I make them available on the network, and they replicate across to all of my peers. And this can happen regularly, and it can happen in a distributed way where changes replicate across the network on the fly. Ultimately, we're still building the same trees of information. It's a question about how it flows and whether there's a central point of failure and a central point of control as those data move. So when we're moving towards this distributed system, the one thing to keep in mind is that the tide has already shifted. So even though it might look like the high tide of cloud services, the water's already moving in the other direction. We're surrounded by talk of clouds, but the actual technological infrastructure is turning towards distributed patterns because that's what we need right now. That's the only thing that's what actually accommodates what we want to do with our data right now. So I have some ideas about how to think about that when you encounter those needs, but I don't have time to talk about that now, so I will skip past that and tell you the way I'm approaching building this Git for tabular data is that we've set it up as a Code for Philly project. So it's a part of the Code for America brigade here in Philadelphia that there's more information if you go to datjohn.com, but if you would like to meet the developers who are participating in that project, they'll be here tomorrow night, Wednesday night, during the play and share thing. We'll be in one of the breakout rooms, coding and looking at our GitHub project and taking assignments and working on code. So if you want to meet us, come along. And that's all. Thank you.
All right, great. So if you just came in late or something, we're going to do about a 15-minute panel, kind of just touching on some of the themes that we talked about during the speakers' presentations. We got a bunch of great questions in on Slack and IRC, et cetera, so thanks for those. But if you have a question and you're here in the audience in person, you want to queue up at one of the mics, and we can kind of work that into the dialogue. But to get started, we kind of had a great question about the notion of like skills, and would there ever be like a spreadsheet system for RDF or something along those lines? And it gets to a bigger question of like more complexity versus simplicity, and do you think it's like a skill-based thing or a tool-based approach that we can kind of start moving into RDF?
Yeah.
Great.
So I think there are. It's really hard not to look at myself in this TV. I'm just so beautiful, so touched. So yeah, I think there's a couple of different ways you can read that question. One is if you take kind of a tools first approach. There have been a number of, I think, different ways to sort of link RDF and tabular data. And I don't mean that in the literal sense of RDF being focused on linked data. I mean just sort of playing at that interconnection. So there's one which was this research project called TripCell, which I think came out in probably 2009. And it was designed to allow you to bring in RDF data into what was effectively a spreadsheet format, so it would be easy for you to manipulate. There's also CSV on the web, which when I originally submitted my talk, I was actually going to do this whole more sort of extended part of my talk on how, I sort of started out my talk by saying, well, CSV is not really a spreadsheet in my definition, but when you add a set of interpretation rules defined by the CSV on the web standard, then I think that in some ways can be treated as sort of a minimal program because it changes how that data is interpreted. The other thing is, I guess it's sort of, if we're talking about spreadsheets for RDF, it's, I think kind of the larger question is, what do we need out of those tools? We see a lot of, frankly, sort of weird visualizations of RDF, a lot of circles and skittles and dots and lines, and I only think those are marginally useful past sort of providing the introductory concepts. So I'm kind of wondering what something like a visual programming interface for RDF looks like. I know there have been a couple of those, but they've been research projects that have been based in the European semantic web community, and they just haven't really sustained themselves. So,
Yeah, Christine, do you have any comment about like, so obviously there's no like pre-baked tools. There are some things like OpenRefine, but is it more it's more of like a skills question rather than like a tools thing for this kind of work?
I think it has to be at a certain point, just because OpenRefine became really helpful because we were migrating data. So we were already in a workflow where the data was being pulled out of whatever system and we were doing stuff to it, and then we pushed back into another system. But a lot of what I'm actually looking at is going to be dependent on what I need to do to get the data out of the platform it's hanging into without relying on a migration workflow. I don't want to have to migrate every time I want to do batch updates or data remediation or anything like that. And that's where I've really had to start relying more and more on scripting my own, just because the variety of how schemas might be interpreted by platforms, the way you might access data in that platform, the way you can do updates, it's sort of all over the place. I would like to see tools like OpenRefine better supported. I'm glad Ted mentioned Karma as well. Vivo and Vitro, the underlying platform for that, I think are really interesting and should be used more, but I don't think we're ever going to get away from the fact that there's so many ways to get to our data, and there's so many interpretations of how our data should look like that you can just have one tool to do all of that.
And I would just add that it's been my experience working with some of these tools that the tool can help you build some skills. So you're working with the text processing and the reconciliation tools in Refine, and you go to the Wikipedia page for the algorithm that you're using, and you learn about this, and you learn to speak the language, and then you can push the limits or choose another tool that might address it better.
Okay, great.
Just really quickly to add on that, I learned scripting, Python scripting, by working with open refined reconciliation services that you set up originally, and I just plugged and played and was trying to figure out how they worked. So +1 to exactly what you just said, but also thank you everyone here who has ever shared their code, however insignificant you might think it is, although I think yours was great, I wasn't saying. But however small you think it is, thank you for sharing it, because I'm definitely lurking, and I learned from it, so.
So there's also a question of, like in the distributed diagrams and networks and things like that, there's always sometimes an authority, right? There's like the Wikidata or maybe ID.LOC or something like that. Do you see that as contrary to this kind of distributed data model? I mean, are you always going to have that official authority to kind of reconcile against? This can go to both, or anyone who wants to chime in.
I spend a lot of time thinking about that lately. I think, so what that makes me think of is that there was this conversation at the LODLAM summit a couple years ago where they were talking about CC0 with linked data. And a lot of the CC0 would be the Creative Commons license that allows you to basically do whatever with the data, and it does not require attribution. And a lot of the people in the room said, but basically assume that that meant that everyone who consumes the data is going to strip out the attribution. They're going to throw it away because we didn't require it. When that seems so strange to me, because the main thing that makes data valuable often is knowing where it came from and knowing who that authority is. So I think that plays a prominent role. That's like why I'm fascinated with trust, is there's this prominent role to authority in any system where people are exchanging pretty much anything, but especially information. And so I think we will inevitably maintain those patterns of a notion of authority and representing that authority and being able to acknowledge and work from that center of authority. But how that manifests in the system, I think, is kind of an open question. I think it's going to evolve over time.
But you definitely see it reflecting more towards like local authority, so local areas of expertise as opposed to a centralized.
I think, so for example, let's just use an example, the id.lc.gov. The fact that that information has been vetted by the Library of Congress is a core element to the value of that data. And so, but in order for it to have that value, it doesn't need to be coming from an LC server, right? It just needs to be provable that this is the data that LC released that I'm using. And so that's the thing that will persist, is being able to say, yes, this is the LC data, and I can prove that it's exactly what they released. But in terms of how it will move, it won't move through central servers, because that's just a bottleneck.
And we got a lot of questions, and I think from the engineers and us saying, in this distributed system, latency, it seems like a huge problem. And so how are we going to get over that notion of, remote servers and this inherent problem of latency if we're trying to build this web of data? And I'm sure everyone here, Christine, you were telling me yesterday that you were blocked by ID.LOC for, going too fast. So like, is that going to be solvable through some sort of technological means, or how do we get towards that?
Hello? Okay, sorry. So I'm not going to talk about the technological means. What I'm going to say is that I think we have a parallel opportunity here. There's a lot of data that I'm very glad to have data coming from the Library of Congress, exactly because it has been vetted and it has that trust attached to it. But I also see that the update mechanisms are not the most approachable. And it doesn't fit with a lot of the workflows we need for a lot of the data and entity resolution work we're going to be doing. So in combination with trying to make more distributed copies of that data so that it's more accessible, maybe more efficient, if that's LDF, linked data fragment servers, if that's something else. But on top of that, having it stored in other places so that we can put our own assertions on top of that we may not be able to or not want to at this time push back to the Library of Congress. And that's where we've looked at things like Vitro and Vivo project to get that data, pull it out, keep it up to date, understand where it's coming from, and then say, okay, let's add some other information about that. So they're sort of parallel, but not really answering the question you asked.
I would make, is this on number 2? All right. I would make a distinction between two notions of distributed. So there's distributed as in multiple services that are in different places, and you are pulling from all of them on the fly to do something. So that's where the services are distributed, as opposed to the data allow the data to move around to where it's needed, and distributed in that sense of the data is distributed across the system and can move. You can have the data that's relevant for me, I pull copies of it to where I need it, without losing. So think about the LC data. As soon as it's with the current sort of server-centric notion, as soon as you take it outside of that service, that server that says this is the LC data, you lose the sense that this is provably the LC data, right? If you made it possible to distribute that data so it could exist on my computer and I know and can prove this is the LC data, that changes the pattern where the information, the data can move around to where it's needed, which then addresses latency issues, which is important when you're dealing with 500 zettabytes of stuff coming off sensors.
I think the other thing that I would add there specifically is that I think you're going to have different tolerances of latency depending on your trust model. So, for example, we're not just saying that we trust Library of Congress's data. There are some domains where you will say, I trust Library of Congress's data right now. I trust the state of this record at this particular point in time. So I think this builds on a lot of what was in Matt's talk in particular, is why we have to care about provenance. It's not just that, yeah, we care that you said this. Like, well, maybe one day, like, you sold out and you did something bad and we don't trust your copy anymore. Or maybe that there was a serious error that was introduced at some point. Having that revision history or being able to refer to that specific point is really good. There are technical solutions to do that. They are very complicated. And so there's a degree of trade-off. I mean, I think I'm in agreement with Matt, is we can be doing a lot better, but right now, sort of the tendency is to say we will work with this known snapshot of data at a particular time. If we can document that as a form of evidence, then I think that's all the better.
And so in this system, trustworthiness kind of incorporates errors as well. So, I mean, if you make an error, or error is propagated across the network, it's not necessarily intentional or a matter of trust. It's just data is messy all the time. So would this system kind of auto-correct for that? And, like, whose responsibility is it to fix errors?
I find inspiration in looking at how people use GitHub. And so I have a lot of experience with the Hydra project. All of the things that we do as engineers of requiring tests and not accepting a pull request unless the tests pass, and all of those things are practices that we have built up around. Once you have that fundamental layer of sort of referenceability of the data and transparency, then there's kind of practice. There's social practice on top of it, and I think those things need to evolve. I am eager to see them evolve. And I think a lot of those solutions sort of already exist in the engineering world. In other ways, they exist in the libraries world. And yeah, I'm interested in seeing how we can apply those things.
We saw a couple different types of entities that you're working with, right? So personal names. Ted, you showed some journal titles. Are there other entities out there beyond the traditional, like, subject headings, terms, people, corporations, et cetera, that kind of might be enabled in this kind of networked environment? Are you looking towards, like, what other kind of entities could represent in this kind of linked data area?
Well, I really want unicorn entities, just because that'd be a lot of fun. No, I I start with the entities that I work the most with in library data, and that tends to be personal names, that tends to be things that were controlled headings in MARC. That doesn't mean that that's all that there is, but until I figure out what we can do for that, I can see where I would like to be able to have to reconcile against other entities in improved fashion. I think like something like article titles, or like even articles is in scope in the near future for that, as we're trying to link our MARC catalog better with our Vivo instance. But this is part of me where I'm putting the blinders on so I can at least fix the problems for the things that we already have floating around.
I guess I would just add, following the Wikidata project a bit, you can see people creating entities for their favorite sitcom episodes and things like that. So, if you want some inspiration of different types of entities that people are cataloging in this, take a look at the Wikidata mailing list. It's pretty fascinating.
Great. So I think we're at time. So please join me in thanking our panelists.
Okay, so I'm standing between you and a break, so we'll be quick. First of all, after the breakout sessions, we're having lightning talks, and I have the list of rooms for the breakout sessions. Okay, I will announce. Hey, does anyone know if there are slots left on the lightning talks? There are 2 slots left on the lightning talks. If you are really gutsy and you think you can write a lightning talk in the breakout session slot, go for it. Otherwise, we'll just say that the lightning talks are there. To make lightning talk life a little easier tomorrow, we are now going to be opening lightning talks signups for tomorrow morning. So like today, there will be 10 slots. And if someone would be so kind as to make that happen on the easel board, I would appreciate it. Thank you. Okay, so breakout session topics and locations are now being announced by me at this podium. Docker, if you want to talk about Docker, we're in the Brownlee room. Fedora 4, the Claypool room, III. Did people really say IIIF, or is there like a shorthand? Triple IF? Okay, that's a lot easier. In the Cook room. Virtualizing vintage technologies flower room, user testing in the Frampton room, as in face-melting guitar solos, XML technologies in the William Penn board room, Docker, Bromley room, Fedora 4, Claypool room, Triple IF, Cook room, virtualizing vintage technologies, flower room, user testing, Frampton room, XML technologies, William Penn. If you have a lightning talk, please make sure you get it on the thing during break or during the breakouts. Breakout sessions start at their respective rooms at 2:45 and at 3:40. We will be back here at 3:45 for housekeeping, which includes many fabulous giveaways. So make sure you get back here on time if you want to win fabulous prizes. And enjoy your break. Thanks.